Okay, we're now going to look at measuring and classifying angles. This is lesson 1-4. Notice these two rays. They're intersecting at point A. An angle is created by intersecting two rays. The rays are known as sides of the angle, and the intersecting point, which is A in this case, is known as the vertex. So A is the vertex. That's the intersection of the two rays. The rays are known as sides. Now let me add some more letters on here. So I have ray AB and ray AC, which are the sides of this angle. To name an angle, you must use its vertex. Since this is only one angle, we can name it angle A, or we can use the three letters angle BAC, or backwards CAB. Notice that the vertex must be in the middle when you use the three letters. Also notice the symbol that's in front of the three letters, or A. This is a symbol to represent an angle. You must always use this symbol when you want to name an angle. Let me add another ray, ray AD. Now I no longer just have one angle, I have many more. I drew this arc to show that the angle I want to look at is the larger angle. That means the angle that you can go from D to C. So remember, we have to use the vertex in the middle. So to name this angle, we would use the symbol of the angle. Then we would use D, A in the middle, and then C, or backwards. We can no longer use angle A because now we have three angles. I have no idea which one you're talking about if you just put angle A. We have angle DAB, or backwards. We have angle BAC, or backwards. And we have the larger angle DAC, or backwards. Protractor postulate is just like a ruler postulate. It's basically taking the angle and putting it to numbers. So look at this protractor. Notice it goes from 0 all the way to 180, or on the other side from 0 all the way to 180. Now the angle GJ, that one is exactly 180 because it goes from 0 to 180. Notice ray HK. Ray HK is being matched with numbers. It's intersecting the protractor at 55. That is the protractor postulate. Now to measure, we can either go from 0 all the way up to HK, which would be 55 degrees, or if we look at the other side, that would be angle GHK, which would be from 0 to 125. So that would be 125, but that's from GHK. Another way that you can solve is by using the absolute value, because again, you will never have negative degrees. So we could look at 0 and 55, subtract the two numbers, and of course that's 55. That would give you angle JHK. Let me say I want to find angle LHK. Notice ray HL is at 90 and ray HK is at 55. All I have to do is take 90 minus 55, and that would give me my degree. So that's how we find the measure of the angles. Do you know the name of these angles? I want you to tell me what is the classification. What are their names? If you need to, stop the slide to take a few moments to look at that. The first one has a 90-degree angle. That little box represents it's a right angle. So that has a degree of 90 degrees. So its name is a right angle. The second one, notice the dotted line tells me that it would be a 90-degree angle, but the blue ray is underneath that 90, so it's less than 90. What's its name? Acute angle. The third one, notice where the 90 degree is. It's bigger than that one, but it's not quite a straight line, so it's between 180 and 90. It's an obtuse angle. Now I want you to name all the angles of the diagram, and I want you to tell me which angle is a right angle as well. If you need to, stop the slide and take a moment to look at it. Okay, so are you able to name all the angles in the diagram? Well, we have angle PQR. Remember, you must use Q in the middle. So PQR is smaller than 90. Angle PQS, that's the bigger angle. That is the 90 degree. And angle RQS, and remember on all of these you could have also gone backwards. That is also less than 90. But angle PQS is the right angle. Now, I need you to draw a pair of opposite rays. Remember, the initial point is the point that's between, and it forms a straight line. What type of angle do the rays form? Not a straight line, that's not an angle. Tell me what you think the name is. Take a few moments if you need to. Stop the slide. Straight angle. We call a line a straight angle when we're using it as an angle. Otherwise, we just call it a line or opposite rays. But we wanted to name the angle, so it's a straight angle. What's its measure? Its angle degree is 180 degrees. Now we're going to look at angle addition postulate. Now angle addition postulate is just like segment addition postulate. It's where we're taking two parts and we're going to add them together to create a larger one. So if point B lies in the interior of angle AOC, then, now interior means it's lying in between the angles. So we have a point floating around in there. Now I'm going to read what the angle addition postulate is, and then I will describe it. Measurement angle AOB plus measurement angle BOC will equal measurement angle AOC. Sounds confusing, right? Well, let's put a picture to it. Pretend those points are on those rays. You know my drawing on a computer. So let's look at the first angle, angle AOB. First of all, I'm sorry, let me first tell you what the little m stands for. That's our abbreviation in geometry. That's measurement of. So the little m stands for measurement of, and then you read the rest of it. So let's first look at angle AOB. So measurement angle AOB is represented by the red rays there and that little arc that I have drawn. The other one is measurement angle BOC, and that also is represented by another arc. Now notice when I put those two angles together, they will give me the larger angle that has O as the vertex, AOC. That's the larger angle. So angle addition postulate is just like segment, where you add two parts together to equal a whole. Notice that they must be adjacent to each other, that is, right next to each other. They have to be attached using the same ray, ray OB in this case. So let's use angle addition postulate. Given that measurement angle XYZ equals 72, find measurement angle XYW and measurement angle ZYW. So let's look at our picture. Angle XYZ is the larger angle. We're saying that that whole angle is 72 degrees. The smaller angles, angle XYW, is 3x plus 6. And the other angle is WYZ is 2x minus 9. We don't know their degrees, but we do know that when we put them together, they will equal 72. So we're going to use angle addition postulate. So using angle addition postulate, we set up our equation. Measurement angle XYZ, the larger, equals measurement angle XYW plus measurement angle WYZ. Now we're going to go ahead and substitute the numbers in. So we get 72 equals 3x plus 6 plus 2x minus 9. Now we just solve algebraically. We're going to combine like terms. So we get 72 equals 5x minus 3. That's because 3x plus 2x equals 5x, and the 6 minus 9 is minus 3. Now we're going to go ahead and add 3 to both sides. And we get 75 equals 5x. And then, of course, last but not least, divide 5 from each side, and we get x equals 15. Now, is that our answer? No, it is not. Now, I don't believe I showed on the slide what the answers are, but now you would take your 15 and substitute it in to measurement angle XYW. So 3 times 15 plus 6 will give you your answer. I'm going to ask you in class what that answer is. And then measurement angle ZYW is the 2 times 15 minus 9. I'm going to ask you that one as well. Now on this one, you're going to do on your own. I want you to find the measure KLN and measurement angle NLM. Now notice they do not give us what the whole angle equals, but you should know now what a straight angle equals. So measurement angle KLM equals a degree. Take a moment, pause the slide, see if you can do this on your own. If not, wait for me, I will do it with you. Okay, by measurement angle KLN, the obtuse angle that you see there, and measurement angle NLM, the acute angle, if I add them up, they will equal the larger angle, the straight angle, KLM. Now I substitute numbers. So I have 10x minus 5 plus 4x plus 3. It's going to equal 180. I combine like terms. I then subtract, or in this case, actually add to both sides, and then I divide, and then I get my x answer. I substitute it back in to get my degrees. Now, actually in class, we'll be asking you how to set this up and solve. So be prepared to show me the work. But your final answers do come out to be 125 and 55. And you can check those by adding them up to see if they equal 180. Here's another one that I'm going to have you do as well in class by showing me the work. So now this one's telling me it's a right angle. Do you remember the degree measure for a right angle? Because that's what you need to add the two to equal. Take a few moments, and if you need to, stop the slide. Okay, so now what I would do is I would take measurement angle EFH plus measurement angle HFG to equal measurement angle EFG. That is, I would take 2x plus 2 plus x plus 1 equals 90 degrees. I would combine like terms, subtract from both sides, and then divide. Then, of course, that only gives me my x, so then I would have to substitute the x answer back into 2x plus 2 as well as x plus 1. My answer is 60 and 30. Congruent angles. Just like congruent segments, congruent angles also will have a symbol. Remember when we had the congruent segments, we used tick marks. Well, with congruent angles, we will use arcs and the same amount of arcs. So in this case, you see that they both have 1. If I had 2 on angle ABC, I would need 2 on angle DEF, and so forth. Just like the angles, I can state that measurement angle ABC is equal to measurement angle DEF. That means they have the same measure. But if I want to write a congruent statement, I have to get rid of the little m's and put the equal with the squiggly like I did before to represent congruent. So angle ABC is congruent to angle DEF. Angle bisector is just like the segment bisector, but it's a ray that bisects the angle. It divides it into 2 congruent angles. So angle DEF is congruent to angle FEG. If that's so, then we know that EF is a ray, and angle DEF is congruent to FEG. And I'm sorry, EF is an angle bisector. Now we're going to solve with an angle bisector. In the diagram at the right, ray YW bisects the angle XYZ. That means that the angle XYW is congruent to angle WYZ. Now they tell us that angle XYW equals 18, and we want to find the larger angle XYZ. Okay, well, let's look at this. If angle XYW is congruent to angle WYZ and angle XYW is 18, what do you think angle WYZ is? And then from angle addition postulate, can we find the larger angle? Try it on your own. Take a few moments. Stop the slide if you need to. Okay, so now we know that the two angles are equal and it bisects. So that means they're congruent. So that means angle XYW is 18 and so is angle WYZ. They're both 18. So by angle addition postulate, we're going to take 18 plus 18 and it will equal 36. So our answer is 36. Now tomorrow I will ask you to give me the answer to the essential question. And we will look at a little bit more in depth the angle bisector and the congruent angles. See you then.